Hi everyone, my name is Pradyumn Kejriwal, and today we will discuss the solution to the 19th problem from the CP sheet by TLE Eliminators under the rating of 1400. So let's begin. As you can see, I have my sheet right here, and this problem, it is called Ball in Berland. At the school where Vasya is studying, preparations are underway for the graduation ceremony. One of the planned performances is a ball, which will be attended by pairs of boys and girls. That is, in a ball, the pairs of boys and girls dance. Okay. Each class must present two couples to the ball. In Vasya's class, A boys and B girls wish to participate, but not all boys and girls are ready to dance in pairs. Formally, you know K possible one boy, one girl pairs. You need to choose two of these pairs so that no person is in more than one pair. For example, if A is 3, B is 4 and K is 4, and like these four couples are ready to dance together, then maybe we can choose one this couple and one this couple, because as you can see, like the boy is not common and the girl also is not common in them. So like, or you can choose like 1 3 and 2 2 also. So there are many possible combinations which you can choose, but these ones are not possible. Like 1 3 and 1 2, it is not possible, like because even though 1 3 are ready to dance together and 1 2 are also ready to dance together, but here the boy 1, like this boy of the number 1 is common in both of them, so it is not possible. And similarly 1 2 and 2 2 is also not possible because this girl number 2 is common. Find the number of ways to select two pairs that match the condition above. Two ways are considered different if they consist of different pairs. Alright, so what you have here is a very simple question, like to state that you have basically some girls and some boys in the class, and there are k pairs of boys and girls. That is, let's say AI comma BI. You have k pairs AI comma BI who are ready to dance together, like they are ready to dance together. Okay, and from them you have to choose two pairs. You have to choose two pairs such that the boy and the girl are not repeated in those pairs, right? So you have to find the number of ways to choose. Okay, right? So for example, in the samples we have this sample. I think it is the same as the one given in text, so I'll just explain this one. So you have four possible couples, right? So we have the boy number 1, girl number 2, or we have the boy number 1, girl number 3, or we have boy number 2, girl number 2, or we have boy number 3 and girl number 4. So basically we have these four pairs who are ready to dance together in the ball, and you have to select two, right? So which ones are allowed? So let's say these two, they are not allowed. Like we cannot put this couple and this couple to the stage because this one is cheating. I mean, this one is in both of them, right? So we cannot do that. So this is not possible. Now if we take this one and this one, not possible because 2 is repeated, right? But then we can take this one because it is not repeated. Then let's say these two, it is possible, and also these two, it is possible because no one is repeating, and also these two is possible. So basically we have four pairs, this 1 2 3 and 4, right? So the answer for this test case is 4, because we can choose 4 pairs out of these k pairs. Like you can choose the number of ways to choose two pairs out of these 4 pairs is 4, right? That's why the answer is 4. Okay, and similarly you can figure out the other test cases as well. So for example, in this one, the n is just 1, like k is just 1, so there's only one couple who is willing to dance together, and so you can't send two couples from the class, right? And this one also you can just figure it out by yourself. And the constraints here are that A, B and K are all up to 2e5. Alright, so since we know that in 1 second we can do around 10 to the power 8 operations, right, in one test, therefore we can say that, like, since k is less than equal to 2e5, we can do like O of k or O of k log k time complexity, but not O of k square. Not O of k square, because this k square will pass this 10 to the power 8 limit. It will be like 4e10, right? K square will be 4e10. So it will take too much time to run. Okay. So yeah, you can just try and pause the video now to solve this problem by yourself. Okay, so I'm assuming that you have tried the problem by yourself and you want a solution now. Alright. So what we can actually do in this is, let's first discuss an O of k square solution. Okay, so if you could have done it in O of k square, then what would you do? In that case, you can just iterate over all the pairs. Like, see, here, as you can see, we have 4 pairs, right? Like, we have 4 possible couples and we can choose 2 of them. So what if we just check all of these pairs? Like, let's say I check this pair and I see that the boy is common. Then I check this pair and I see that the girl is common. So similarly, I'll check all of those pairs. So how many pairs are there? There are KC2 pairs. KC2, right? Because we have K couples and we have to choose any 2 of them. So there are KC2 pairs of couples. So we can iterate over all of them and it will take like O of KC2 time. KC2 time, that is O of k square time, right? But that will of course not pass. But that's one solution upon which we can build up, right? So instead of doing like just iterating over all of the pairs of couples and counting that which ones are valid, what we can do is do the reverse. That is, just ask ourselves that which ones are invalid. Okay, so basically, which pairs of couples are invalid? Like, if I take 1, 2 and 2, 2, it is invalid. Like, this pair of couples is invalid because the girl is common in both of them. So the invalid ones have either a boy common. Like, let's say I chose 2 couples, like I am iterating over this. Let's say I am iterating over all of those pairs and currently I am at, like, let's say AI comma BI, that is the ith pair, and AJ comma BJ, that is the jth pair. So I am checking if they are like valid or not. So they are valid. Okay, if they are invalid if and only if AI is equal to AJ, that is the boy is same, or BI is equal to BJ, right? So that is invalid. These pairs are invalid. So how about we just take the total number of them? Like, how about we just take the total number of pairs of couples, that is KC2, and from that we subtract the invalid pairs. Right? So basically now at this point we have to count the invalid pairs. Like, if we can count the invalid pairs, of course we can just subtract it from the total and we'll get our answer. So how do we count the number of invalid pairs? So as we know that in an invalid pair, either the boy is same or the girl is same, right? See, both cannot be same, because if both, like, it is guaranteed in the input. In the input, it is guaranteed that each couple is listed at most once, right? So they have told us that in the input, among all the pairs, no 2 pairs are the same, right? So both cannot be same, but either the boy will be same or the girl will be same in an invalid pair, right? So what we can simply do is just count that. And how do we count that? Is one idea is that, okay, let's say that in my pair I have a boy called A and a girl called BI, and one more pair I have and the same boy is there, A, and the girl is BJ. Okay. Then I need to count the pairs of this type, right? So what I can just do is I can iterate over A. Like I can just fix this A. That is, I'll check that for boy number 1, how many such pairs are there. Then for boy number 2, how many are there. Then for boy number 3, and so on. So let's say I want to find out that for boy number 1, how many pairs are there such that like 1 comma bi and 1 comma bj. So I'm counting that how many pairs are there such that the boy number 1 is the boy in both of them. So I'll subtract that from my answer, right? So how do I find that out? That is just what, like if the number 1 comes in 3 couples, like let's say 1 comma 2 is a couple, 1 comma 1 is a couple, like girl number 1, and 1 comma 4 is a couple. Okay, so 1 comes in 3 couples totally. Okay, so what we can simply do is to count the number of pairs in which 1 comes. That is just 3c2. Like choose any 2 out of these 3. Let's say this one and this one. So this pair is invalid, and let's say this one and this one, this is also invalid. So basically, and like okay, finally this one and this one. So 3 pairs, that is 3c2. These many pairs are invalid because 1 is common in both of them. So I just did it for 1. Like I knew that 1 was in 3 pairs, so I just did that for 1. Then you will do it for 2, then for 3, and for so on. So you will do it for all the boys. That in how many pairs there are, like let's say they are in some m pairs, then mc2 is the number of invalid pairs because the boy is the same, right? And then we can just like add that up, and we will get the number of pairs which are invalid because some boy is the same, right? And similarly we can do it for girls also. Like see, we just counted the number of invalid pairs in which the boy is same, right? But one more option is that the girl can also be same. So we'll count that as well. Like we'll just iterate over all the girls, and we will do the same thing, that if the girl has n partners, n possible partners, then we'll just add nc2 to our answer, right? I mean subtract from our answer basically. If we are counting the invalid pairs, then we'll add it, right? So that's the entire solution. Like it's pretty easy, to be honest, that you just have to count the number of invalid pairs and subtract it from the total number of pairs of the couples. And the invalid pairs are that one boy or one girl is the same. So we can just iterate over which boy it is, and let's say that that boy has m couples, like that boy is part of m couples, then mc2 pairs are invalid due to that boy, right? So we can just iterate over all the boys and just subtract all of them from our kc2, and finally we'll just get our answer, right? And so yeah, this is the entire thing. So just we have to maintain that for every boy, that in how many couples it is there, right? And for every girl also, we have to maintain that in how many couples she is there, right? And then we can just do this. So it is pretty simple, and I'll just show you the code for this also. So here in the main function I have the fast IO and the typical test cases stuff, and then in the solve function I have int abk, c in abk, then I have count 1, count 2. So this count 1 and count 2, like this count 1 of I stores that for boy number I, how many couples it is a part of, like basically how many girlfriends does the boy I have, right? So I'm just taking in the input int temp, c int temp, like basically in the input they have given first the list of all boys and the corresponding list of girls. So I'm just making, like I'm doing c in int temp, c int temp, like the index of the boy, and just increment its count, right? And -1 because of 0 indexing. And similarly for the girls also, I'll just do int temp c int temp count 2 of temp minus 1 plus plus. And then I'll initialize the answer with kc2, that is k into k minus 1 by 2. And for all the boys, I will, like, basically for all boys, the frequency I'm taking in this x variable, and I'm subtracting xc2. Okay. And similarly for all girls, I'm also subtracting xc2, right? And finally I am printing the answer. So this is the entire logic of this problem, and the time it takes is, like, this for loop is O of k, clearly this is also O of k, and this for loop iterates over all the elements in count 1, that is the boys one. So it will take O of number of boys time, that is O of a, and this one will take similarly O of b. So the TC of this is O of a plus b plus k, right? And the space used is, like, we have made these two vectors frequency vectors of a and b size, so it will take O of a plus b space. So the space complexity is O of a plus b. All right, so I think this should be pretty clear, and thanks for watching.